Well, thank you all. This is such a pleasure, and I'm really grateful. I do physics. I'm interested in sort of active matter, and so that talk with the bees and stuff was super interesting to me. And Bob and I know each other from doing some of that, and emergence theory. But for the last 5 or 6 years, I've been consulting with the foundation, and my job has been primarily to try to build a community of scholars, all of whom are addressing key questions in intelligence. And so, of course, I get to think my own thoughts sometimes, but not as much as I'd like. And if I had given a talk today, it would have really been about the thing that came up, I think, on the first day about goals and problems. And I like John, I think, question the idea that intelligences do putter around the world solving problems. But I have yet to come to a persuasive way of discussing what we do if we're just bumbling about. So I think that would be sort of the thing I'm most interested in is quantifying bumbling, because that's sort of close to my heart. Obviously, I'm a bumbler. But so what I'm going to do today is nothing about that. I just want to tell you about the program that I've been involved in and leading the sort of content side of, and invite you into a conversation. So it's been called the Diverse Intelligences Initiative. We've been going for a while. I'm going to give you some slides that I used when I kind of pitched this to the trustees. We went before the trustees, got an initial envelope, and went back for a second one. And so a lot of what we have to do with every foundation is to speak to the donor's intent. So the donor in this case had a very sort of broad-reaching vision of a universe that was sort of driven by what he would call an infinite intellect. He was a religious fellow, not personally, but many of us really appreciate that sort of vision of a world that is imbued with some kind of guiding, impetus that goes all the way back to the Greeks. You can think of the nous, you can think of the pleroma, the logos. This idea that collectively there's a there are various ways of thinking about that sort of collective intellectation of the world. So, but if the world isn't just about problem solving, what would be another way to think about what those big ideas amount to? And so last couple of days we were talking about apprehension. David was talking about sense making. I think that those are all different approaches into this problem of if we are collectively engaged with lots of different kinds of intellects in the world, and if the world then proceeds in some kind of a coherent manner, what does the action of intellectation do? How does it participate in that process? Is the apprehension resulting in some kind of action? What is the suitability criterion for that action? Do you succeed at solving a problem? Do you decrease local entropy? What exactly is it that intellectation is accomplishing? And I think those are the kinds of questions that aren't asked by very many people who aren't your kind of people, right? So this is what I think mathematicians have to contribute, and I don't think you've done enough, frankly, so I need you. So here's where we are with this thing. The whole overall purse is about $40 million. Much of that has already been dispersed to a variety of grantees, including Jacob and Erica Cartmill, who have done some amazing stuff I'll talk about in a minute. And what we're looking at now is sort of a third phase. So we have this community of scholars, and they stretch across ethologists, philosophers of science, a good number of comparative psychologists. So it took me a while to understand the difference between ethology and comparative psychology. If you've got 2 hours, I'll walk you through that. But animal critter people. And a lot of folk who think about the differences in the way humans interact with one another. My question to you a little later will be, what is it that you would like to know more from the empiricists who work in those worlds? And then, the easier question, because we all think we have a lot to offer, is, what should you be telling them? So I'd like to hear and think through with you is this third phase, which is if you have a community of people who have worked on intelligences across these various domains, what should we do to make that community relevant, to actually bring that kind of interdisciplinarity to bear on the world? And what could you all offer? What would you like to be involved in doing? So as Blue knows from Jacob's summer schools, they've done an amazing job at building a coterie of folk who are sort of coming up into what is notionally an interdisciplinary field or a community. The question is, how do you operationalize that, and what should we be doing next? What can we all do? This is just a silly slide that sort of gives you a sense of our overall timeline. We're pretty close to the end of the primary timeline, and that's exciting and disappointing for me at the same time. Like, my work here is done, but now we have to figure out whether we just walk away from it and hope it's a thing that lives on, or find ways to continue it. So I wanted to give you some examples of the kinds of things that people are doing who aren't mathematicians. Some of these are very systematic, so you may be familiar with the idea of the major transitions in evolution. That was originally authored by Svatmari and his co-author Smith, and they established a kind of a saltatory. This goes back to as you know, the 19th century theories of evolution by saltation. They suggested that there would be transitional, qualitatively different characteristics of organisms, physiological characteristics that would give rise to certain sort of Gibsonian affordances, that you could do different things by dint of being a different kind of structure. These guys, one of our sort of major teams that's working right now, headed by Andrew Barron, has proposed that there is a cognitive series of transitions that have to do with wiring, essentially. Neurophysiological structures don't necessarily give rise to new characteristics of cognition, but give rise to the capacities for new characteristics of cognition. I think that's contentious, and I think it would bear some good network analysis and all the kind of math that you could throw at these things. Super interesting and a nice claim, like it's a good coherent claim. We're calling this a framework of intelligence. It's characteristic of some of the other things that we're working on. So yeah, so these are what we're calling the frameworks of intelligences. The idea is essentially there should be some overarching idea structures that give rise to a sort of spin-off a set of hypotheses that then are empirically testable. So this one's really nice because you can go into the lab, you can look at the difference between bees and hummingbirds, for example, as someone is working on right now, or rats and humans, and say, what are the cognitive capacities that we see? And in the case of hummingbirds and bees, for example, they're both very good at path making and target finding and all that kind of thing, but they're completely differently wired. And bees have 1 million neurons, like a tiny little brain, and yet they can still do waggle dances. So the argument that the lamination or the reciprocal connections that you see in a hummingbird are necessary for those cognitive capacities are small indeed. So here are some of the other frameworks. Jacob is in the process of building out one that has to do with compositionality. We have another one from Tom Griffiths. Many of you probably know him at Princeton. He's a really, really mathematically sophisticated guy in cognitive science. He would like to suggest that there's a multidimensional space in which capacities like what Michael Muthukrishna was talking about, brain size and communications interface bandwidth and duration, durability, can all be mapped onto a highly multidimensional space, and then you might have kind of islands of stability in that space where actual intelligences, good agents, can live. If you could do that, and if you could use some constraint theory and lower the dimensionality, what you could be doing is you could say, look, this is where we ought to look for certain kinds of intelligences. Certain sort of cognitive capacities would live over here, others would live over there. And if there are blank spaces where we haven't looked, that would give us a nice guide, like, oh my goodness, maybe fungi do occupy, or the root systems of trees do occupy a natural niche within this high dimensional space. Again, I think a lot of the people who are doing this work are, they're not very cognizant of the problems associated with dimensional reduction. So these are places where good mathematicians, I think, could be greatly helpful. So where we're at now, and I just want to really, again, give credit to Jacob and Erica. We've done summer events every year. We do a summit, what we call a summit, to which I extend you all an invitation. It will be taking place in St. Andrews this summer. We gather we've had between 80 and 120 people, again, across all of these different fields for about 3 days. And we offer people a chance to talk to one another as much as possible. So there's very little talking at and a great deal of talking with. And then Jacob and Eric at the same time have been doing this Summer Institute, which is for young scholars. Some of you younger people might want to apply to that this coming year. And we've had sort of postdocs, graduate students, and young faculty members come. So we're going to be doing it. We decided it was the 5th time coming up. Wow. So we'll be running that for a while. Pat, did you put your hand up? So these are sort of the discussion prompts. And really, this is completely, I just want to hear from you. Like, based on what you think you know about the way people talk about intelligence, what would be helpful to know more about? Like, would you like to hear more about how ants actually swarm? Would you like to hear more about homing pigeon dynamics? Would you like to hear more about the actual ways humans talk to one another? What would feed your mathematical work, give you the sort of empirical basis that you think would make your work more robust? And then I think probably easier for you to answer would be the question, as you listen to the literature, or you watch the news, or you read science and nature papers, what makes you cringe the most? Like, where are the people just not being mathematically sophisticated? And what could you offer? Who's the person that you could sit down with and set them straight? So in the vein of what Jacob did the other day with his discussion prompts, let's take the first one for a second and just pause and think on it, and then I'll just ask us to talk.
I don't know. I mean, this is very, very specific to stuff that I worked on in the past. But like, how much do you work with people doing neuroscience?
Sorry, you'll have to talk a little
Sorry.
more louder.
How much? I mean, are there people working on neuroscience that have data from like fMRI scans and like EEG, like that kind of experimental?
Yeah, I mean, there's a ton of. So I'd be curious. What do you want from that? So what he's asking about are brain scan stuff. So what you get out of those data are broad regional characteristics of activity in living brains. So those tend to be highly aggregative. So what would help you with that?
So the stuff that we've looked at where that's interesting is extracting connectomes and graph of networks from that data, and then relating that to different pathologies in brains.
Mm-hmm.
And then seeing what structural, which are definitely at a macro scale and have a lot of noise involved depending on machinery and whatnot. But, we've been able to distinguish different types of pathologies.
And so you were saying the other day that you have a proposal that distinguishes between comatose and just sort of inactive brain cells.
Right. But I guess the issue to actually validate something like that is that it's very hard to get that kind of data because it's private, because it's expensive to create, and then because these are people and it's their information.
Right.
There's also a lot of ethical considerations. So being in a larger context where all of these things are done correctly would be useful.
So I mean, and this is great. So Jacob will take notes, and you and I can talk about that. But just quickly, there's the Allen Institute for Brain Research in Seattle is working on the connectome of a mouse and human. Andrew Barron, who I mentioned, has pretty much nailed the bee connectome. So that connectomics work exists. And then similarly, we have a bunch of folk. There's Walter Sinnott Armstrong and his colleagues at Duke. And they've gone to Eastern Europe where this is easier. But basically, if you're epileptic and they have to localize the source of your epilepsy, they often put indwelling electrodes in your brain for a while and wait around for you to have a seizure. And so those data are at hand. So that kind of thing exists. And then there's Andy Meltzoff in Seattle also has a lot of fMRI work on children in various brain states, but I don't think any of them are inactive. So, but yeah, okay, so that's great. I mean, there's the kind of thing we're looking to hear.
I'd be interested from I talked to Michael Evan, but I want a kind of larger, a bunch of people to answer a question of kind of why am I here? But if a problem was given, to solve, I would like to know how evolution has evolved the capacity for you scrape some stuff off of a frog leg and it like makes a little thing that works. Like are we universal Turing machines, or what is it that's like enabling problem solving, new niche creation? Like what is it that organizes things so that they can kind of deal with some new arbitrage opportunity? Like there's some new like, oh, we realize that there's some picnic over there, let's go get the food or the oil or whatever. What is it that enables this to happen over and over in life?
So I'm thinking of Yogi Bear. So what sort of empirical work would that arise from?
I think it's like the creation of organization or organs, like what decides how the kind of what the individual is, whether it's individual liver, individual heart, or the individual ant or individual like job within ant colony. Like what decides like division of labor in a recursively all the way down kind of way.
Did you want to jump in on that, Pat? I have an answer too.
Well, I was just going to sort of compliment it, so you should give an answer.
Well, so let me just go back to Mike. So Mike has been sort of spinning out this story he tells, which is, I guess he calls it cognition all the way down. He's got a nifty acronym for it. And so the notion is that, and this goes to Bob's work as well, that there are scales, appropriate scales of analysis on which aggregation and collective activity are meaningful. And so I think it would be super interesting to really drill down into the question you're asking. Like, is it where aggregation gives you new dimensions of, new affordances, essentially? Or are those baked in? Is there some kind of existence in potential that resides in certain structures that when you get enough of them, they will automatically give rise to? And I think to a certain extent, that's what Jacob's idea on modules and compositionality hopes to find is, do you already know that certain low dimensional things, if put together, will give you some higher dimensional capacity? And I think that, so Levin would obviously be a good person to talk to. We have a sort of a group of theoretical evolutionary biologists who have begun to think about that work too. Pat?
There were a couple issues that were but also in other talks.
I'm sorry, I have trouble hearing people through a mask.
Stand up.
I think without seeing lips, there's like secret lip reading that we all do.
Yeah. So there are a couple issues that came up across talks that I think are really interesting and maybe get to the point of what intelligence might, which is a combination of scaling and goals. And so your goals have to change as you succeed. Sort of bigger and bigger things and greater organization, and like that's in this talk, of course. This part of what Bob was talking about. It was also at the beginning with the ants and things like this. Sort of, and there's one hard question that I think isn't quite answered well anywhere. There are lots of them, but like, what are the goals? Like, where do the goals come from?
Yeah.
What are viable? And it's not everything, right? Because we do this sort of systematically and constructively. In this case, like there are discrete qualitative things. What makes that so? How does that how do you continuously change that? Or
so who can, what sort of lab scientist can answer that question for you?
I think that's a good question. I think lots of them could. I think one that's not here, that was touched on by Josh, is children, right? They sort of do this crazy stuff all the time.
Right.
They're definitely creating goals for themselves that they then try to achieve, and they come from who knows where, right? But that question of what are viable goals is one that I think is sort of, or however you want to think about them, is one that probably guides intelligence, and the sort of interesting kind of intelligence is not just a goal, but sort of keeping it going and sort of producing greater structure.
Yeah, so that's really cool. So one of the people who's on our organizing committee but couldn't be here is Alison Gopnik, right? And so she's, for those of you that aren't familiar, she's made her name in this sort of explore-exploit trade-off thing, which isn't exactly goals. So you'd have to be talking about like a meta version of explore-exploit, but it's costly to explore. Like you wander around the world if you've got a patch, and we know other people who work on patchiness, but if you've got a patch of resources that are rich, how long do you exploit those before leaving the patch and finding other, looking for other resources where you could potentially starve on your way to the other oasis? So I think the same thing applies to sort of goal acquisition in a meta sense. So then there are people who, and I think she's thought about this too, is there, sometimes people call this philosophical rational, and I know it's, Colin Allen hates it that people call it this, but can you set up a system for thinking about explore, exploit that is consistent with your notion of what's optimal? And so then you'd compare, you'd do like a, alternate worlds kind of a modal analysis and go, would I be more rational? Would it be better if I chose this strategy than that strategy? And then that gives you the sort of acquisition of goals in the sense that you choose a strategy that has that goal embedded in it. But yeah, so the child psychology people have definitely worked on that, but then Jacob's colleagues, and you can speak more about the people we know who have done like patchy analysis of patchy grazing and things like that. Peter Todd, yeah. Go ahead.
So this is something that I guess I've been thinking about like very recently, and I haven't, like, no one talked about it at this conference yet, but like I would be really interested in learn more about like how language like influences how we like perceive and represent our worlds, because like the way we speak is not just a series of like words and patterns. Like it's grounded in like how I interact with people and how I interact with my world and environment and how I've grown up. And I don't know if this research has already been done, but like I just feel like that there needs to be more connection between like how language influences interactions and my representation of the world and stuff.
Oh yeah, I mean, you'll have a great time exploring that world. So cognitive linguistics and, there's a lot of sort of mathematical linguistics can provide you a lot of that. But like Terry Deacon, you might enjoy Terry Deacon's work, The Symbolic Species. And this question of reason making. So we have a psychologist named Bahar Koyman. She's Turkish. And the question is, how do you, so we've been talking about persuasion a lot in the last few talks. So say you get together with people and you're like, I want to do X, you want to do Y, let's talk about why we should do one versus the other. And so the first thing you might do is you might exchange truth warrants, like I believe we should do X because I did X yesterday and it worked. You could also say there's someone I trust who has done X and that person says, it's great, we should do that. So you undergo this linguistic processing, a collective, if you want to think in Bayesian terms, you're like sharing internal states and blah, blah, blah. But she says, look, language itself pre-structures a lot of that. So in Turkish, when you make an assertive statement, it already builds in the verb forms, like this is, I know this because, is already sort of implicit in the way you speak. And so that's really cool. And I think in any symbol system, and this goes to mathematics, right? You can sort of choose how much is carried with the symbol that as a feed in. But that's great stuff. It's really rich. So just in a couple of minutes, John, you want to leave? Don't.
I have to leave. I don't want to leave.
All right. Well, before you go, what I know what you're going to say, right? It should be more category theory. But what do people need in the world that you have to offer the intelligence studies people?
That I have to offer?
Yeah. I mean, the mathematical community, you all.
I don't know. I really don't know. I wouldn't have.
Applied category theory?
Well, I don't know. I sort of already made the point in my talk is that if someone wants to apply category theory, it'd be really good to team up with a category theorist and think about it in a slow, relaxed, patient way to try to find like what's something that really works.
Mm-hmm. Well, thanks, and we should let you go so you can.
Yeah, I'm afraid
I mean, the second part of our little discussion here, Dima is going to lead us, and basically that slow, relaxed way of putting things together would be exactly what we'd hope for in a long program, where we could have a bunch of those folk that I was mentioning come with a bunch of you and spend, at least one of the workshops on applied category theory, and how could that, feed the work that they're doing. So just in a very few minutes, and if you don't have anything to say or you feel like it's sort of arrogant, you don't have to, but looking around the world of cognitive science, for example, which is a more familiar way of framing it, what do you see as lacking? What do you think they're mathematically inept about, if anything?
I've already sort of made this point in my talk, but I think I don't talk about this necessarily, but I think there's a real limitation having algorithms intervene between models and predictions. There are real problems with that because in order to generate a prediction, do a simulation, you're then going to be throttled by computation. You're then not going to be able to systematically reason about how you propose things.
Interesting.
This is sort of very standard in literature and part inspired by machine learning. But
Cool. Did you write that down? I want to get back to that. And you have one person here.
Hey, Sean.
Hi. So I was just thinking, I don't know if there is such a study or not. So is there any mathematical study of body language? I mean, it's kind of
Yeah.
to communicate. I heard, I don't know if it's correct or it's just some common sense that they say 70% of the message is in the body language. And I don't know if that's correct or not, but I think body language is important. And I haven't seen that much work, mathematical work of body language and how we can get message by artificial intelligence from body language instead of, because usually body language is really harder to fake than like.
Yeah, it's a great one. And Josh Bongard wrote a book in like 2006 about embodied cognition. Embodied cognition would probably be a key phrase you could look up. And gestural communication would be another one. Obviously motion capture and stuff like that. But Jacob's wife, Erica Cartmill, is an expert in gestural communication in non-humans. I don't think it's been very mathematicalized, but that would be an amazing collaboration that I could imagine taking place. So any other sort of thoughts? Go ahead.
Well, another
Pablo.
couple of comments for the second question of what can the math community offer intelligent researchers? Oh, so I'll try to speak louder. So yeah, you were asking about if you have this subspaces of intelligences. So by now there's a collection of techniques called manifold learning, which allow you to infer like more structure from the data that you've collected. And yeah, there's a number of things that you can do there and a number of different algorithms, some of which I'm familiar with. So that could be, provided you have the data in some format, you could apply it to that and then get more information and then see how that makes sense.
Cool.
So that's one thing. And then for the other one, like what messages haven't they heard yet, or what, I don't remember exactly how you phrased it, but like what would you like to see cognitive scientists do? I think one really good example that we saw this week was with this dream scope architecture that combined different inputs and had like the rest and the kind of self-feedback of dream mechanism maybe built in. But also, I think having diverse inputs from like visual, audio, and text signals put into the same framework, that's something that's starting to happen as well in machine learning and deep learning architectures, combining all of that into a single learning mechanism. So I know that's like maybe too ambitious because all of these experts work in very different, very highly specialized fields. But I think that's probably what would be the next good step to try to take. I mean, it's hard, but
Yeah, differently structured data streams, combining them.
yeah. And there are mathematical ways of combining them using optimal transport recently of like mixing different data sets and then making sense of these different data formats using optimal transport.
Neat.
So that you can then like measure them, take derivatives and like feed them into some sort of learning, like deep learning architecture.
Yeah, the information theory stuff is a little light, especially in certain subfields, so that'd be really cool. Last one, David?
I do want to stick up for, apparently it's getting very hyped, but okay, apply category. That is that like someone in their talk said, no one knows, we're all learning 19th century math, we're not even learning 20th, let alone 21st. But I taught someone here like the basic definition of categories, products, and Cartesian closure, which are three things, in about an hour. And like from there, you can learn you can learn that stuff pretty quickly. You don't need you don't need any background in calculus at all. You can learn 20th and 21st century math, and then from there, learn the other things as a kind of common hub. So like a hub for a lot of mathematics. All it's doing is capturing the structure you're going to see again and again throughout math. And so I think one thing I would tell like people in science is like, there is a pretty easy, like, okay, it's a mind-bending thing. You turn your mind sideways in a way you've never heard of before, but then you realize you've actually been doing that a lot anyway. You just didn't know anyone had a name for it. And so like, I think there's something that's not that hard to learn that could really help with understanding a lot of different.
So that's something that we could really do at a workshop on a long program, for example, is if you brought a bunch of applied category theorists together and a bunch of people who weren't particularly mathematical, you think you could sort of feed them a new way of thinking about things that didn't require them all to be good with matrix theory and calculus.
Not at all, yeah. And what it would really be is like, tell me what you're doing, and I will like I think what category theorists are trying to look for is help people express what they're already doing, that we're not experts at, that they are, and just have it be kind of part of the common language.
That's perfect. That's a great transition. So Dina, I'll ask you to talk a little bit about what the long program looks like, and then maybe we can sort of think about what would a workshop be. So we've already established that one's on applied category theory, right?